to chapter 4. If you look at the topic for today, we've already covered some of this because, some of the examples or activities were more fun if we added, for instance, tap to them to make them a little bit more interactive. So this chapter is not a huge surprise, I don't think. Nothing in here is gonna shock you. There are a few little quirks having to do with how Solar 2D draws some of these shapes, and so I'll try to focus more on what those quirks are and how not to get caught up in them. So we've done text already. There are many more things we can draw in the display table. The basic shapes are line, square, rounded rectangle, circle, polygon, and also image. These are all built into the display table, so they will be drawn essentially in the same way that text was drawn, except obviously for each of the shapes you're going to give different parameter information. For the text, as an example at the top, you give it a string, an XY location, a font to use, and a font size to use. You obviously don't give that same information to all of the shapes. That wouldn't make sense. So for lines, and we actually did touch on lines last time, you give it two XY values that represent the starting point and the ending point for the line. Rectangles, you give it an XY value, a width, and a height. The XY value will be the center of the rectangle, the square, the shape. So unlike other languages where the XY component locates, say, the top left corner, the XY values in Solar 2D are going to designate the center of the shape. That actually is a nice feature because it makes it super easy to center stuff easily on your small display. Rounded rectangle takes the same parameters as rectangle in addition to an integer number which represents the rounding you want to apply to all four corners. New circle takes the XY, which is again the center, and then the diameter of the circle in pixels again. Polygon is a little bit more complex, so we'll go over that in a little more detail. But you do pass it an XY value, which represents the center of the polygon. And then you pass it a table of XY values representing the vertices or the points that define the polygon shape. New image rect is what we'll use to display images on screen. You pass it a file name and a width and a height. So you might already be looking at these and thinking, wait a minute, there's a little bit of inconsistency here and there. Or certainly there's some differences between other languages if you're used to other languages. But I think even if this is your first language that you're really digging into, for instance, the display new image rect takes a file name and a width and a height. What about the X and Y? What about the X and Y value? Where's the image displayed? It's weird. Okay, so we'll jump into these, and we talked about not problems, but potential issues with text last time, mainly centering on how do you know what fonts you can use, and what happens if you don't use those fonts. So we're moving on to some special considerations with the shapes. So I list 3 special considerations in the keynote, and we'll just tackle those in order. So first off, there's circles, right? Let me go back to, sorry, there's the new circle function. It's built into the display table. It draws a circle, and you pass it a diameter. So what if you don't want a circle, right? I mean, circles are nice, certainly. People like circles, but what if you need an oval? With those 3 parameters, you can't specify non-circular shapes. So the way you do it is you set the width and or the height afterwards, essentially allowing you to stretch the circle any way you want to create the oval that you want. But it takes that extra step. There is no new oval function, and there's no way in just that one line of code creating the circle that you create an oval. You've got to size it after creating it. So second special consideration, which I already which I already gave you a heads up on, is the image is weird because it doesn't specify the XY value. And that's just the way Solar 2D does it. You specify the X and the Y value after the fact. So you create the image object using new image rect, passing it the information that it needs. The width and the height are used to scale the image as you want. And then after that's done, you can specify the X and the Y value. All right, then the polygons. So the polygons are always a little bit, more confusing, a step more complex because they're a step more complex. They're multi-edged shapes that can actually get quite complex. So there's different syntaxes for doing this, but the basic syntax is you just create a list of XY values. So for instance, to draw this triangle, we would need to locate each of these three vertices. So we would need a table of XY values that have a total of 6 integers in them. And the order may or may not matter, but it's certainly each of these pairs is an XY value. So I've done a poor job here. I normally group the XY values together and put an extra space between each set of XY values just visibly so that it stands out, at least in my mind, a little bit better. But any extra spacing and stuff that you do in here to help you see is not necessary. The vertices just need literally 6 integer values separated by commas. Solar 2D will read that in and use these as the first pair, the second pair, and the third pair of XY values. And then to create the polygon, you'll use that table. You'll pass it that table of XY values and where you want the polygon located. So that's actually a little bit confusing because you've just passed it a bunch of XY values, right? If this triangle was really at 50 over 50 down, 100 over 100 down, and 50 over 100 down, then that should locate it on screen. Those are actual on-screen values, so then what is the purpose of this XY? So it's interesting. The way Solar 2D does it is these vertices do not locate the polygon. Rather, they simply define the shape. So the polygon gets its shape from these points, but not its location. The location is given when you create the polygon. And it'll be the center of the polygon. This is actually a nice feature again because it means you don't really have to worry about where you put your shape when you define it. You just worry about the shape. And then you can place it wherever you need to place it easily when you create it. Or of course you could use table.attribute syntax to say later object3.x or object3.y equals whatever you want it to be. Those are what jump out at me as the three things that maybe need a little bit of discussion. Oh, I skipped colors. Sorry, colors. Let's talk about colors and then gradients, and then we'll jump over to drawing a code and do some of this stuff. So we already know this because we've done it. You can fill shapes with a color, and you can set the outline color. Those are 2 separate colors. It's one shape, but you can give it 2 separate colors. The thing that confuses people more than anything is just that the outline, or what Solar 2D calls the stroke, has a pixel width that you can set, which is great. That's not the confusing part. The confusing part is it defaults to 0. So when you create a shape in Solar 2D, and I follow that in drawing a code to be consistent, the shape does have a stroke, but it's set at 0 width. So if you set the stroke color and don't adjust the stroke width, you won't see the stroke color because it has a width of 0 pixels. So if you want separate fill and stroke colors and want to be able to see them, then you have to set the stroke width to some positive value. That's the first trick, and it trips everybody up one or more times. Okay, then gradients. Sure, solid colors are great. Everybody likes solid colors, but gradients are a step more fun. So a gradient is just a blending of colors. Solar 2D supports just this single two-color gradient. So you select both of the colors. Solar 2D calls them color 1 and color 2, which kind of makes, I mean, you might think, well, why doesn't it call them color top and color bottom, or color left and color right? Well, it's because you can switch the directions 4 different ways. So giving them a more descriptive name doesn't really do anything. It's just the first color and the second color. And then you can program the gradients to go from color 1 to color 2, left to right, or right to left, up to down, or down to up, just by specifying the direction as a parameter. So for instance, if I did set up a gradient with this kind of green color and this kind of gold color, and I set it to go to the right, it would look like this in Solar 2D. So it starts out with that green color, then slowly blends it over to the yellow goldish color. The syntax is a little bit, I don't know, a little bit fiddly. You might look at that and go, that is a lot of typing. Of course, for all of these, if you're using Draw to Code, it's just done, with a button click and in this case, then a selection of 2 colors from a color chooser, a color picker. But the syntax, if you're typing it by hand, the syntax you will see generated by Draw to Code, and maybe that you'll want to edit to do something else with, will look something like this. So you create a table. Here, I've called it G here. This is a table. You know it's a table because the data is wrapped in these curly braces. So anytime you see a Lua identifier set equal to something in these curly braces, you know it's a table. So again, a table is a structured or organized bit of data that you've given a name to. The name in this case is G, and it contains structured or organized data. And in this case, it's 4 key value pairs. And I've divided them up into 4 lines just to make it easier to see. But the first key value pair is, the key is type, the value is gradient. The second key value pair is the color 1 key with then another table, which is an RGB set of values. So this is a table within a table, which is perfectly fine. Color 2, same thing. It's a table of RGB values. So 0.4, 0.6, and 0 is this greenish kind of color, and 1.80 is this gold color. And then we give it a direction. So the 4th key value pair is direction equals, and then one of those 4 directions, up, down, left, right. So to create that exact same gradient I gave you on the previous slide, nothing changes about how you create the shape when you use a gradient. The gradient gets set by calling set fill color. So you can set the fill color to an RGB value or a gradient. So in this case, I've passed it G for the gradient, and that would give us this gradient filled rectangle sized and placed wherever you want it. You might be wondering, I don't know if you're wondering, you're looking at that and going, well, how on earth is Draw to Code going to do that? So there is no set gradient button, since it's actually just a variation of a fill color. Instead of adding another button to the UI, I've put it in with set fill color. So there's a fill color button, and if you press Option on a Mac, or Alt on Windows, so that's the key that is next to adjacent to the space bar, and that is usually used to access kind of alternative or optional functionality. If you hover over set fill color and Draw to Code, you'll also get this description that says Option or Alt click to select the gradient. So literally all you do is you hold down the Option or the Alt key, depending on the platform you're using, and click the fill color, and that will then open up a chooser that lets you select the gradient that you want to use. Certainly, if you want to follow along, you can. I'm not going to do anything complex. Everything we're talking about here is a display object. So the default palette that shows up in Draw to Code when you launch it is the display objects palette. So You've got line, rectangle, rounded rect, circle, polygon, text, image, image sheet, gradient, and display group. We have not talked about image sheet and we have not talked about display group yet. All the other stuff falls into the category of just the very basic shapes that you can do. So let's try to do kind of a basic Solar 2D logo kind of thing. So there's a circle, and this is where if you stretch it now, you can get an oval if that's what you want. In Drawn to Code, you resize stuff using the sliders, or with the slider selected, you can use the cursor keys on your keyboard. And there are a variety of little keyboard shortcuts, which if you hover over, it'll tell you. One of the ones that's really handy is with resizing stuff that you want to keep the width and the height the same. So I programmed it so if you hold the Shift key down, it'll toggle this link between the width and the height. So if you link them up, there's a little gray box around them. And then when you size either one of them, they both resize. And you hit Shift again to make that link go away. All of the stuff, or most of the stuff, I hope shows up in the tooltips. If you take a second to hover over stuff and you see a tooltip, it's almost always worth reading. If I took the time to program in, a tooltip, it's because that was important. Okay, so to make this look more like a sun for the Solar 2D kind of logo, let's set the fill color something, I don't know, sun-ish. How about that? And then let's set the line color or the stroke color something a little more red or orange, salmon or something. All right, let's try that. Okay, so right off the bat, I've set a fill color, I've set a line color or a stroke color, but we're not seeing the stroke color. We're seeing the fill color, the gold, but not the orange-ish color. So we're not seeing it because we haven't changed the stroke. The stroke is set to 0. You can see that because the stroke is set to 0 right here. So if you want to see that orange stroke around the outside, you've got to increase the stroke to some positive value that results in it showing up. So if you find yourself setting the stroke color on a shape and then you're not seeing it, it's probably because you haven't set it right. Let's add some text for, let's say, Solar 2D. Obviously that's not super visible, so let's make it bigger. Let's pick a fancier font, and let's pick a better color maybe. Not sure what that'll look like. That looks okay. Stack. So we've got two objects, a circle and a text object. So one of the first things to note is just the order. The order is important. When Solar 2D looks at the code that's generated, it's going to go top to bottom. So for the most part, in simple script stacks, it's going to go from the top of the script down to the bottom of the script. So the circle is drawn first, and the text is drawn second. What's drawn later, lower in the stack, lower in the sequence of drawn elements, is drawn on top of what was drawn earlier. But this is literally just drawing these things in order. These aren't really layers. They're just drawn shapes, and you're just layering one shape on top of the other, kind of like you're painting on top of something that you've already painted. The stuff that you paint later will show up on top of the stuff that you draw earlier. And you can play around with this if you want by rearranging what was drawn. So if I if I select the text and move it up the stack, then what you see is the text disappears. If I want to switch this back, I can just rearrange it so that what is on screen is what I want to see. Let's save it because I want to be good about setting a good example for you guys in terms of naming stuff. So I'm going to call this I'm going to create a folder for chapter 4. All I did was I went to I've got a folder I made one mobile designs. I think I made that last time. The one is there just so that it sorts up to the top to make it easy. All I'm going to do is type a name for the design. So I'm going to call it, how about Solar 2D Logo. Let me run it, but I'm generating the code and hitting the run button. You guys see the Solar 2D logo showing up. I think it looks pretty much exactly like it does in Draw in Code. That's certainly always my goal. Let's add a gradient though. Let's take it the next step. All right, so I do frequently use gradient backgrounds. There's a super simple gradient background that's in Draw in Code as a snippet. It's in snippets, gradient background. It just essentially inserts the text for a grayscale gradient background, and it's not configurable. If you wanted to change it, you'd have to go in and edit the code. That's not impossible, completely doable, but it's not really what we want. I want a real editable script object that has a settings panel that we can adjust to get the effect that we want. So let's create the gradient. What I want to do is I'm going to create a kind of a sky background, since we've got a sun image. That'll look cool, I think, with a kind of a sky background. I can name the color, so I'm going to name it sky. And then I'm going to hit the color 1 and color 2 buttons. These will simply pull up a very standard color picker or color chooser. So skies are, obviously skies are lots of different colors, so you can pick your favorite 2 colors. I'm going to pick something kind of dark for one, and then for the second color, I'm going to pick one that's really light. So I've got these 2 colors set. The direction I'm not going to adjust yet because I always like to play around with it and see which way looks best. But now we need something to apply the gradient to. So if I want a sky background behind the sun, I need a rectangle, which Draw in Code creates just a default white 100 by 100 rectangle centered on screen. So I want to make it as big as the display, and in fact I normally go over. Because if you think back to our discussion last time about scaling and different devices and the possibility that we might, depending on our scaling approach, we might get black bars, or if you use the other one, some of our content may be trimmed. And so I don't want the black bars. And I can not get black bars by actually doing something like this behind all of my other work, and then I won't get black. Even if the device screen is quite a bit larger or wider, taller, since I've gone way over the edge, I should never see the black bars. But this is, there are 2 things wrong with this right now, right? First is what happened to our logo. So the logo is not visible because the rectangle is being drawn, object 4 is being drawn after the logo, the drawings. So I need to move the rectangle up the stack, and if you do that step by step, pushing it up the stack, you'll see the text appear and then the circle appear, and now it looks like it did, except there's no gradient. So to set the gradient, I'm going to option click on the fill color button. I will get a pop-up dialog. So it gives me a little pop-up dialog kind of like this, and it will give me the choice of any gradients that I've selected. So I only have one gradient. It's object 3 and its name is sky. It's important to give your gradients and even your shapes names, because when you end up having to do stuff with them, that name might help you much more easily recognize what you're working with, rather than remembering, if you had 3 or 4 gradients and they were unnamed, all you would see on the list is object 3, object 9, object 20, and then you'd have to remember, well wait a minute, which one of these was the gradient I wanted to use? Which one was the sky? Which one was the morning sky? Whatever the case may be. So if you give them descriptive names, then that makes subsequent work with them easier. when you hit it, you should get the gradient effect, and then you can go back to the gradient script object and play around with the direction. So if you hit that direction button, it just cycles through all of the valid directions. Let me save it and then switch back to the Corona. There we go. What is going on? Oh, it's an order issue. Because, so it's great I ran into it, and I would love to say right now that I did this on purpose to make a point, but in truth I didn't. I created the gradient first, and then I used the gradient, which is the order that it needs to happen in, but then I moved the rectangle. So if we look at our stack, what you'll see is that the rectangle is now at the top because I wanted it behind everything else. The gradient isn't defined until way later. We're not getting an error. It'd be nice if we got an error here, if Solar 2D said, hey, you know, gradient's nil or something like that, but it's not giving us an error, but it's not filling the rectangle anymore. It's filling it with nothing, so it's see-through. So to fix it, you'll want to take that gradient and move it up the stack until it is before the shape that uses it. If you do that and save it. So that order will get you the gradient result that you're looking for. Let's look at the code. Some people think better in code. All right. So this is the code that is generated by the design in your stack. And what you'll notice first off is object 3 is highlighted. That's because object 3 is highlighted in the stack. Whichever chunk of code here is selected in the stack, the script object in the stack, what's highlighted in the code window is the code that is generated for you by that script object. So this is the correct order. I create the gradient here in object 3, and then object 3, and then I use it here on what's my line 22 to set the gradient on object 4. If I have those in the other order, which is what I had, then this line of code runs, but object 3 is nil, and we don't get the result we want. So it's just a top-down order issue. Even though I created it in the right order, say in drawn to code, I made the gradient first and then I applied it to the shape. I then subsequently went back and changed the order. All right, so we've hit the magic slide. All right, it's done, it's done. Well, the next slide, this is slide 18, is just if you are at all confused about or potentially confused about or think you're confused about how to draw compound shapes out of multiple display shapes, then go ahead and do some of this or dive into one of the homeworks that has you do something like this. I think this is a good place to quit. Display groups add another level of richness to our coding capabilities, and we'll turn the logo that we made a few minutes ago into a display group, and then that'll let us do some stuff with it that's pretty cool. But let me save that for next time.